Hi everyone. In this video, I'm going to show you how to evaluate piecewise defined function algebraically. Okay, so I'm going to list out the steps. So how do we evaluate a piecewise defined function algebraically? So first, you want to identify the domain restriction in which the x value belongs to. Okay, so I'm going to say, okay, let's evaluate the function when x equal, let's say positive 2. So what you want to do is to identify the domain restriction. What is the correct domain this restriction in which the x value belong to? Okay. Then step 2, you're going to plug in the x value into the function that has that domain restriction. Okay. And then step 3, you're going to evaluate or compute, okay, to find the output. Okay? Since you have the x value, you want to find the output, the y values. So this is a problem that was, So they asked us to evaluate the piecewise defined function for x value of -4, -3, 0, and positive 2. So I gave you a piecewise function. You have a single brace, and it's made of 3 functions. So you see negative 4x, 3x plus 2, and x plus 4 represent functions, okay? And after the function, what do you have? So the inequality on the right, the inequality represents the domain restriction. That's what I call domain restriction, okay? The inequality represents a domain restriction. What does it mean? It means that negative 4x can only exist or be seen or live for the where the x value are less than -3, okay? So if you want to see this on the x-axis, imagine here on the x-axis. So what are all the numbers that are less than -3? So you see that -3 is right here. Let me do a vertical line. So this interval, so all the x value, all the number less than -3 are going to be the number on the left side of -3. So this inequality should be this region, okay, this area represents, is when the function -x can be graphed. It's only in this area. So this is a domain restriction, okay? And now the x value needs to be, for this function to exist, the x value needs to be between -3 and positive 2. So whatever x value on the number line on the x-axis are between -3 and positive 2. Let me show you. So right here, okay? So this represents the other inequality, -3, the second one, the second domain restriction. 3x plus 2 can only be graphed in this region on the x-axis, okay? Now the last one is x plus 4. So x plus 4 only exists or can only be graphed if the x value are greater or equal to 2. So whatever number greater or equal to 2, they're going to be in this area right here. Why? They represent all the number on the right side of 4 are greater than, or the right side of 2 are greater, okay, than 2, greater or equal to 2. So now, so I hope I made, so let me highlight. So now we want to find out when I say evaluate, so you have 3 different domains because you're going to, yeah, you're supposed to, you have 3 different pieces of a function on different domain. So what you want to do next, you want to evaluate x of -4. So x equal -4 belong in which domain? Step 1, identify the domain restriction in which x value belong to. So the -4 belongs to which domain? The first one, the second, or the last one? Okay. Do you see -4 right here? Does -4 belong to this domain? No. It doesn't belong to the green domain. What about the pink one? No. It only belong to this area, to the black domain. So let me highlight. So -4 is right here, because here is -3 and then -4. Okay, so and then you are -5 and -6. So -4 is in this inequality domain restriction. Why? Another way you could see it, if you plug in -4 here, so is -4 less than -3? So let me move up. Is -4 less than -3? It's true. Okay, so if you use a second inequality, right? If you plug in -4 in wherever So where there is an x, I'm going to plug in -4. So is -4 less than -2 and greater or equal to -3? No. Okay, so it's not true, it's false. Okay, it doesn't make the inequality true. If I plug in -4 into the last inequality, okay, let me do that right now. So you have -4 is greater or equal to 2. Does it make this inequality true if I plug -4? No, because -4 is not greater or equal. It's less than, so it's false. Always false, never true. So you can now see that. Okay, I'll show you two ways you can to identify the correct domain restriction, which is the first one. Why -4 is less than -3. Okay, so we know that -4. Let me use a color marker. So I know that -4, okay, belong to this domain. Okay, so we still completed step 1. What am I going to do for step 2? Okay, so for step 2, you're going to plug in the x value into the function. So you're trying to find g of -4. Okay, so we are going to use which function to evaluate? So you're going to use the function -4x. Okay, so let me zoom in so you can see. So you're going to use the function -4x. What does it mean? Okay, so now we want to find out. You're doing this. You're using this function because it's a function that fits that can only live for x value less where the x value are less than -3. So now I have to plug in -4 into the x. So wherever I used to see the x, I'm going to plug in -4. Then I'm going to evaluate or compute. -4 times -4 is positive 16. Okay, so g of -4 is positive 16. So how do we evaluate? First, step 1, we want to identify the correct, the domain restriction in which the x value belongs to. Okay, now step 2, you want to plug in the x value into the functions. Okay, so we know that the -4 belongs to this domain restriction. Okay, then you're going to use that function, which is -4x. Okay, and then you're going to replace the x by its value, which is -4. Okay, and then you find that g of -4 is 16. So now we're going to move and do to the next one. What is g of -3? Okay, so you need to identify the correct domain. Okay, so can I use the first? Is it going to be the first the first domain restriction, the first inequality? Okay, remember -3 is not less than -3. If I plug -3 here, -3 is equal to itself. So the only domain restriction where -3 can live is going to be right here. So -3, okay, belongs to this domain restriction. Why? Because you have a line under the inequality. There is a line under the inequality. So -3 is less or equal to itself, -3. Okay, so that's why I'm going to use that the function g of x equal 3x plus 2. And wherever there used to be the x, I'm going to plug in -3. So -3 times -3 is -9. And then you add 2, you get -7. Okay, so now let's continue. What is g of 0? Okay, the 0 belongs to which domain? Please pause the video and try to do it by yourself. Okay, good luck. Okay, so let's do g of 0. So I know that the x value 0, you need to identify the 0 belongs to which domain restriction. Is 0 less than -3? No, 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 no. It's greater than -3. So now, does 0 belong to this interval, domain restriction? Yes, because you go from a negative number to a positive number. So you have to pass 0, it must be in between those two. Okay, so 0, it will be in that domain restriction. Going from negative to positive means you're passing through 0. Okay, so 0 is very big. Why? Because 0 is less than 2 and 0 is also greater or equal to negative 3. Okay, that's why I'm using that function with its corresponding interval domain restrictions, which is 3x plus 2. Okay, now since I want to find g of 0, evaluate to up, wherever I see the x, I'm going to plug in the 0, and we get g of 0. G of 0 is positive 2. Okay, so now I hope it's making more sense. So let's do the last one. What is g of 2? Go ahead and try on your own. Please pause the video and try. Okay, so let's find g of 2. Okay, how do I get g of 2? So I need to identify the x value of 2. In which interval does it belong to? Okay, let's plug in 2 into the x here. Is 2 less than negative 3? No. So 2 does not belong into that domain. Okay, what about here? Okay, 2 is not less than 2, so it doesn't belong here. So where does the 2 belong? It belongs right here in that domain restriction. Why? If I plug in 2 into the x, 2 is greater or equal to 2. Okay, so the function I'm going to use is going to be the function x plus 4, right? I use the function x plus 4. Okay, then I will place the x by its value because you want to find g of 2, and you use 2 for x, and then you add 4, you get 6. So g of 2 is equal to 6. Okay, so again, to identify the correct, to evaluate piecewise defined function, the first step you need to do is to identify the domain restriction in which the x value belong to. Step 2, you plug in the x value into the function. Okay, I found that, relaxed example, I found that 2 belong to this interval, so I use its function and I plug in the x value. Then you evaluate a compute. Okay, so I hope the lesson was make more sense. Okay, so thank you for watching my video. Have a wonderful day and see you into the next video.